Hello guys, welcome to Algorithm. Today we're going to solve the LeetCode problem of problem number 704. The problem name is binary search. This is basically a search algorithm, but the normal search algorithm takes a big O of n time complexity, but the binary search is especially known for its log n time complexity. It's basically a divide algorithm to search an element faster in a sorted array. Come, let's find out how to solve this problem step by step. See, this is the problem, LeetCode number 704 binary search. And in this problem, see, there is a given input array which is sorted in ascending wise and a given integer target as 9. What we're going to do is we're going to search this target element from this array, and if the element is found, then we need to return the found element index. In this case, the target is 9 and the target value 9 is present in the fourth index, so we need to return 4. See the second case, the target is 2 and in the given input array there is no 2. In this case, we need to return the -1. There are basically two ways to solve this problem. One is the normal brute force method and the second is the binary search method. Come, I'll explain both of this method clearly so that you can understand it well. See, in this case, we have given an integer array sorted in ascending wise, and we have given a target value 9. We have to find the target element from this array. And what's the normal approach is, we simply going to apply a for loop from this to this direction and search for the target element. And if the 9 is present, 0, 1, 2, 3. We simply return that present element index, which is answer is equal to 4. This is a very simple approach, but the problem here is the time complexity. The time this approach takes is big O of n. But there is another optimized way to solve this, where the time complexity will be big O of log n. That's known as binary search. Come, I'll explain you clearly how the binary search works step by step. In binary search, we will given an input array, and what we're going to do is search this element by calculating the midpoint of the array continuously. For example, in the first step, we will calculate the left pointer and the right pointer. Which means we initialize an integer left pointer, which will be a 0th index pointing to, and the right pointer, which will be the last index, which means 0, 1, 2, 3, 4, and 5. The right pointer will be 5. From these two values, we will calculate the mid pointer, which is right pointer plus left pointer divided by 2. In this case, 2.5, which will be mid, will be 3. See, the third element is 5. Third index element is 5. And in the next step, what we're going to do is we're going to see the third element index, which is 5, greater than target or not. Target value is 9. 5 is not greater than target. 5 is lesser than target. Then what we're going to do is we will move the left pointer to mid value plus 1. And what will happen? Now the new left pointer will be, what is the mid value? 3 plus 1, left pointer will be 4. And right pointer will be same it as 5. And we will again calculate the mid value, which means right pointer plus left pointer divided by 2, which will be 9 divided by 3, which will be 4.5. Mid equal to 4.5. We will calculate the round value and we will get 5. And in the fifth index, we have 12. Similarly, we're going to check the 12 is greater than target or not. Yes, 12 is greater than target. If it is greater, then we're going to move the right pointer to mid. Now the right pointer will be mid -1. Here we did +1 to ignore the midpoint and go to the right. And from right, we are coming to the left, so we are adding -1 to ignore the midpoint. Now, The new left point will be 4 and the right pointer will be 4. Then what is the mid value? Mid is equal to RP plus LP divided by 2, which we will get as 4 plus 4, 8 divided by 2 is equal to 4. The new mid value will be 4. Now you can clearly see the fourth index is our target value. In that case, we can simply return the mid as an answer. This is our answer. And if the left, we going to apply this midpoint calculating logic till the base condition is met, which means the left pointer is less than or equal to right pointer. If in case we have crossed the left pointer greater than right pointer, then we can clearly say that the target element is not in this given array, and we can simply return -1. I hope you have a clear understanding which I have explained today. Now come, I'll show you how to apply this logic using C# in LeetCode. First we are going to declare two pointers. Initialize with left pointer as 0 value and right pointer as array.length. Then we're going to apply a while loop until a condition is met. What will be our base condition? Left pointer must be less than or equal to right. See. And we will calculate the mid value. Right plus left divided by 2, and once the midpoint is calculated, we will check the mid value is equal to target or not. The mid value, which is a num array, make the value index is equal to target. If it's true, then we can simply return the mid value. If it's not true, then we will not return, and we will check whether the mid value is greater than target or less than target. Okay. The mid value is greater than target, then we will move the right pointer to left. Else left pointer to right. And once the while loop is completed, outside of the while loop, we will simply return -1. See, this much is the code. Now we can check whether this code is running on test cases or not. You can see the test case are accepted, and we will finally submit this. Yes, now you can clearly see that solution is beating 100% of problem from using C# in LeetCode. Try this code yourself and tell how you feel about this approach in comment section. Thank you.